All right, I'm going to show you in this video how to complete the square. And first, I'm going to talk about quadratic equations still. So far, what we have been working with is quadratic equations in this form, which is called standard. There's also another way to represent quadratic equations. Looks like this. And this is called vertex form, something we haven't talked about yet. And we're going to start to get comfortable with that, okay? So, down here, this is in vertex form. You see, you got those parentheses, and I'll explain more about what this means later. And first of all, what we want to do is let's change it to standard form. So what we would do is we'd have to just, rewrite this x minus 3 2 times because of the squaring. We would then let's not distribute yet. Let's just multiply this out in here. X times x is x squared. You'd have x times this is minus 3x. But then you'd have minus 3 times x again, so that would be minus 6x. Negative 3 times negative 3 is positive 9. And then you would distribute the 2. You get 2x squared minus 12x. Now this would be plus 18. But remember, you have this plus 10 there as well. So 18 plus 10 is 28. So now we just changed it to, standard form. This would be your A, this would be your B, this would be your C. Okay. No big deal. Now here, this is in standard form, and I'm going to show you how to change it to vertex form. But we're going to do that in just a little bit. So before we do that, we're going to do a little refresher. Let's go to the next page. So remember our factoring. Hopefully this should be very fresh, Notice how there's no equal signs in any of these. We're not solving, we're just factoring. You notice here that these, disappearing ink, that's not good. Hopefully it's okay. Notice how this is a perfect square, the 9. The square root would be 3. Everything's plus, and if you do a check, 3x and 3x gives you 6x, it works. And then here, you would notice the same thing. Hey, wait, that's a perfect square. So let's try the 5. And you get 5x, and 5x makes 10x. Whoops, but you see that would make positive 10x. So you see, this tells us that the signs are the same, but this tells us that they're both negative. That would give us the negative 10x. So what you quickly realize is with all of these are perfect squares. So this is just kind of meant to be a refresher on factoring what's called perfect square trinomials. And you see 7x and 7x would be 14x. I'm not going to do all these, but you kind of get the picture here, I think. This one here sometimes freaks people out, but remember, the square root of 1 is just 1. 1x and 1x makes 2x in the middle. So these all end up being the same, just like the first 3. So to complete the square, we want to create this kind of situation. So here's a process that we're going to follow. Make sure that a equals 1. Most of the time it's going to be 1. Don't worry about that. Take a look at this. Take half of b. I'm going to talk through it here down here. So watch this. See, we're going to take this standard form equation and change it to vertex form. And what we do is we're going to rewrite this. And after the 6x, I'm going to leave a little space, and then I'm going to write plus 2 right there. And then what we do here is this b term, we're always going to take this b term and cut it in half. And half of that, of course, is going to be 3. And then you're going to square that, which, of course, would be 9, positive 9. But you see, if I add 9 to this side of the equation, to keep the equation balanced, I'd have to subtract 9 there. So I haven't changed the value of anything. I've just changed kind of how it looks. But what this does for us, just so you know, okay, the whole reason of taking this and cutting it in half and squaring it is it creates a perfect square trinomial. So if we were to factor this, this would end up being x plus 3 times x plus 3, okay? But we don't want to write it like that. Instead of writing x plus 3 2 times, we're just going to write it like that. And now we combine these things. 2 minus 9 is negative 7, and that's what we have hanging off the back. And that is vertex form. Okay? Now again, talking a little bit about parabolas. Every parabola has a vertex. I'm just drawing, this parabola does not coincide with this equation. The vertex is this point right here. It's where everything switches, the symmetry, okay? And the nice thing about this vertex form is knowing what this point is often beneficial. I'm going to do a lot more with this later on. Knowing that vertex is beneficial for sure. And what you do is you ask if I was asked to find the vertex, you ask yourself, what value of x is going to make this parentheses come out to 0? That would be negative 3. And then whatever this is, that's the actual vertex of this parabola. Okay? Simple as that. So here, let me talk you through another one. Again, what do? We rewrite it, and after the b term, we leave a little space. We're going to cut this b term in half, which is negative 5. Square that, you get positive 20. This is always going to be positive, because when you square whatever kind of number, you're always going to get a positive. But to keep it balanced, I have to do that. Again, I have now created a perfect square trinomial. That's minus, remember. This is going to be x minus 5 times x minus 5, but we're just going to write squared. And that would be minus 27. If I was asked to find the vertex, that would be 5, because that makes that come out to 0, comma, negative 27. Now this one looks a little bit different, right? Because it's not equal to 0. So you do want to be equal to 0, just like we've done so many times before. I would always move everything over to the side, and where x squared is positive, so x squared plus 4x, we have to subtract that 7, but I'm going to leave a little space here. Okay, I'm going to leave a little space. Write the minus 7 here. Now I want to complete the square. I'm going to cut this in half, which is 2. Square it. I get 4 again. I have to subtract 4. Remember, this is the same thing as y. So that's going to be x plus 2 squared minus 11. Vertex would be negative 2, negative 11. So that's the only thing that's really different on this page is you got to be, again, move this over. You can picture this as being a y once instead of 0. X squared minus 6x. Leave a little space, plus 6. Half of this is 3. Square it. That's a perfect square trinomial. x minus 3 squared minus 3. I'm not going to write down the vertex. You get the idea here. And here you get, again, x squared plus 4x, leave a little space. Half of that's 2, square it, keep it balanced. This is going to be x plus 2 minus 3. There you go. Now, I'm going to go back to that first one that we skipped. Okay. The first one that we skipped on the first page is what I meant to say. There it is. So we can do this now. Leave a little space. Half of this is 4, square it. Balance it. That's going to be x minus 4, if you factor it, minus 2. There you go. That is what we call completing the square. Okay.